In this part of the Computational Intelligence course, related to fuzzy systems, we will continue fuzzy set theory. We will try to understand the analogy between classical logic, Boolean algebra, and propositional logic. The classical set operators are defined by using traditional logic operators. Let X be universe of this course, that is universal set, then A intersection B is defined as the collection of points belonging to universe of this course such that these points X is element of A and element of B. The union of A and B is the collection of X points belonging to universe of this course such that X is element of A or X is element of B. The complement of A is the collection of points such that these points are not element of A. That is, collection of X points such that X is element of A is not true. The subset A is subset of B if and only if X is element of A implies that X is element of B for all X in the universe of this course. One idea to define fuzzy set operators is to use fuzzy logics. Classical logic deals with propositions, either true or false. The propositional logic handles combination of logical variables. The key idea is how to express n-array logic functions with logic primitives. For example, the logic functions not, and, or, and implication. A set of logic primitives is complete if any logic function can be composed by a finite number of these primitives. For example, consider not and or. This is a complete set. Any logic function, binary logic function, can be implemented by using these three operators. Or only these two, not together with and, is complete because or can be obtained by using these two, and then it is equal to that one. Any function can be implemented. Not operation and implication, these two is complete. Nor operation by itself is complete, and also NAND operation is complete operation. When a variable represented by logical formula is true for all possible truth values, that is, it is called tautology. False for all possible truth values, in that case, it is called contradiction. Various forms of tautologies exist to perform deductive inference. They are called inference rules. For example, A and A implication B, implication of B, then this is called modus ponens, and it is tautology. This one, not B, ended with A implication B, and then we have implication not A. This is called modus tollens, another tautology. A implication B and B implication C, implication A implication C. This is hypothetical syllogism. You note that A implication B is equivalent to A complement or B. For example, if we consider modus ponens, if we are given two true propositions, A and A implication B, these are called premises. Truth of proposition B, this one, conclusion, can be inferred. Every tautology remains a tautology when any of its variables is replaced with an arbitrary logic formula. For example, consider this one. Instead of A, any logic formula can be inserted. Or instead of B, any logic formula can be inserted and it will remain as a tautology. The propositional logic based on finite set of logic variables is isomorphic. That means having same structure to finite set theory. Both of these systems are isomorphic to finite Boolean algebra. Here is the definition of Boolean algebra. A Boolean algebra on a set B is defined as quadruple B, which is a set B, operations plus and dot and not, where B has at least two elements, 0 and 1, and plus and dot are binary operators on B, and this one is the unary operator on B, for which the following properties hold. These are the properties. Idempotence is saying A plus A is equal to A, or we can say this one as A or A is A and A is A. The second one, commutativity, A or B is equivalent to B or A, and this is the dual of this one. Instead of this plus operation, insert dot operation. A dot B is equal to B dot A. B3 is associativity. It is saying that A or B or C is equivalent to first apply or operation between B and C, and then or with A. And dual is first dot operation and operation between A and B, and then apply and operation between C, and the result is equivalent to first apply B and C, and then apply A and with the result. Absorption is saying that A or A dot B is equal to A, and this one is the dual. Instead of plus, insert dot, and instead of dot, insert plus. So this is the dual of the absorption rule. Distribution, P5 is distribution. This is saying that A dot B or C is equivalent to A dot B or A dot C. And this is the dual one, A or B dot C equal to A or B dot A or C. Universal bounds, A or 0 is equal to A or 1 is equivalent to 1, A and 1 is equivalent to A and 0 is equivalent to 0. Here notice that when we are taking the dual, 0 is replaced by 1 or is replaced by dot, and if there were dot here, it would be replaced by plus. So this is the dual part of the universal bounds. The complementary is A, or A complement is equal to 1, and dual is saying A and A complement is equal to 0. B8 is involution. Complement of A is equal to A itself. Here it is same for the dual part. Dualization B9, A or B complement is equal to A complement and B complement. Dual is A and B complement is equal to A complement or B complement. Boolean algebra can be characterized by a partial ordering on a set. That is, A is less than equal to B if A dot B is A, or alternatively, if A or B is equal to B. If we consider set theory, Boolean algebra, and propositional logic, every theorem in one theory has a counterpart in each other theory. Counterparts can be obtained applying the following substitutions. Here the meaning is written, and it is explanation, the corresponding part in set theory, in Boolean algebra, and propositional logic is given here. The values is in the set theory is all possible subsets. In Boolean algebra, the set B itself, and in propositional logic, values of the proposition. AND operation in the set theory is corresponding to intersection. It is the dot operation in Boolean algebra, and it is this AND operation in propositional logic. Join or operation, this is the union in the set theory. In Boolean algebra, it is represented by the plus symbol, and this is the symbol for OR operation in propositional logic. Complement or not is shown as C in the set theory, and this minus in Boolean algebra, or prime is used instead of this one, and this is the complement in the propositional logic. The identity element is the universal set in set theory. It is one in Boolean algebra and one in propositional logic. Zero element is empty set in set theory. It is the element 0 in Boolean algebra and also 0 in the propositional logic. The partial order, this is the subset in set theory, less than equal to in Boolean algebra, and this implication operation in propositional logic. Power set 2 to the power x, set of logic variables V, and set of all combinations, propositional logic V, of truth values of V. So here in the set theory, all the values are power set 2 to the power x. In Boolean algebra, it is B, set of logic variables V, it is B, set of all combinations of propositional logic values of truth values of V in propositional logic.